Hi, this is Divya, Assistant Professor, Biomedical Engineering Department in SNS College of Technology. In this video, we are going to see about the structure of PN junction diode, how the PN junction diode looks and how it works in its practical consideration and how the output will be produced by this PN junction diode. Okay. A semiconductor diode, as I told you already in the previous video, it is a semiconductor diode where it will conduct to a certain limit or a certain point where the silicon and the germanium will have they both are the semiconductor materials where it it conducts at a certain point of voltage. That is called that turns the normal diode into a semiconductor diode at the particular range. Okay. A semiconductor diode is a two-terminal electronic component with a PN junction. It is also called as rectifier. Okay, this PN junction diode is also called as a rectifier, which is used for rectification purpose. Where rectification is that when the input signal can be of a sine wave, and by using a rectification process we can reduce the noises produced in the input signal, and we can produce the output how the application according to the application the output will be produced. Okay, we can have we'll be having a different kinds of rectifiers in it. Okay, in this PN junction diode we have two terminals. Okay, one is called anode and another one is called cathode. Okay, anode will be of a positive terminal and a cathode will be of a negative terminal. You can see in this diagram that A is called anode, K is called cathode. A is a positive terminal and K is a negative terminal. In this, in the right side we can see the practically how the diode looks. Okay, see, the anode will be of completely black in color, coated with a black material. That is, and the negative part, that is cathode, will be of little gray in color. To identify which is cathode and which is anode, we can see that the gray in color is called the cathode and the completely black in color is called anode. Okay. Next is how it has two types of biasing conditions. What are they? Is that forward biasing and reverse biasing. Forward biasing is nothing but the positive how the diode gets in a positive voltage, and the reverse bias is nothing but how the diode works in the reverse condition, that is negative condition. Okay, see, in this practical diagram we can see that anode is connected to the positive terminal and negative, that is cathode, is connected to the negative terminal as such. In this can be used in the practical consideration. How this gets the forward bias condition works is that we'll be having an ammeter connected to it to identify how the current, ammeter and a voltmeter also, how the current and on voltage increases in the diode by using the diode, PN junction diode. Okay, the PN junction, when the supply is given, we can see the electron flow, right? Electron flow from the positive side to the negative side, which enters into the N type, and then it moves on to the P type. It gets recombinated each other. This P type and N type holes and electrons gets recombinated, and again it will be move on to this complete complete process goes on like this. Okay, while by using this ammeters and voltmeters we can identify the current and the voltage occurs in this PN junction diode, how the current and then voltage increases or decreases and what kind of the procedure it works on. Okay, and it is a reverse bias condition. We can see that cathode will be connected to the positive terminal and the anode will be connected to the negative terminal. Okay, in this reverse, in the forward bias, that is positive terminal condition, positive terminal connection, as the voltage increases, the current will also gets increased. Okay, as the voltage increase, will have a combination of holes and electrons over that, will have a depletion region also. So before that depletion region occurs, will have a increase, that is increase in, as the voltage gets increases, currents also gets increases. In the reverse bias condition, after the depletion region occurs, it will move on to the reverse bias condition. So in that, then the diode will change in the reverse bias condition. So when the voltage decreases, current will also get decreased. Okay, this is the process of PN junction diode. A peak inverse voltage can be defined. We'll have a peak inverse voltage, where it is that, what it is, that is the maximum reverse voltage that the diode can withstand without being destroyed. The reverse voltage, the maximum reverse voltage, that is negative voltage, right? The maximum negative voltage that diode can withstand is called the peak inverse voltage, which can be occurred or measured by the PN junction diode. The peak inverse voltage is that the maximum inverse voltage, that is reverse voltage, negative voltage, that a diode can withstand. How long it can withstand, that is called the peak inverse voltage. Okay, which will occur only in the reverse bias condition. Next, okay, VI characteristics of a diode. What is called VI characteristics? As I told you already, VI, that is voltage and a current. How the diode increases, works in the forward bias and also in the reverse bias condition. In the forward bias, as the diode current increases, voltage also gets increased. Okay, and the reverse bias, the voltage gets decreased, as such the current is also get decreased. We'll have an ammeter, voltmeter and a resistor in the practical consideration. Okay, the resistor is to resist the flow of current which is directly passing to the external power supply voltage. Okay, if the direct supply is given to the diode or ammeter or voltmeter will get destroyed. So we will be adding a resistor in front or immediately after the power supply. Why? Because the resistor will resist the flow of current, and it will send only how much the diode requires or the circuit requires. Okay, thank you.